Hey guys, today we're going to do a video on solving systems of equations, because this is something that comes up a lot in grade 9, grade 10, grade 11 math, and oftentimes it's simply the process of writing down the appropriate equations to set up the system of equations that can be the trickiest part. And so I wanted to do one example where we simply solve right away, and one where we have to establish the equations before we can actually solve them. And so if we get started, our first example gives us y is equal to 2x plus 3, and then x plus y is equal to 5. Okay. Now, I'm going to use substitution because I do believe that this method translates better into higher levels of math and more complicated kind of functions. And so this one is going to be a bit straightforward because we're already given an equation in the form of one variable in terms of another. So when we read an equation like this, we say that this equation is given to us in the form of y in terms of x, because we have an equation for y that is in terms of x, that is written in some combination of stuff with x, okay? So we read this as y in terms of x for our first equation. Now, because y is equal to some jumble of stuff involving only x, we can substitute it right into our second equation, okay? So we can replace y with 2x plus 3. And if we do that, then our second equation will look like x plus, remember, y is 2x plus 3, so we can replace this y with exactly 2x plus 3, okay? And we still have the fact that is equal to 5. And so now we can combine like terms, right? As we learned in grade 9, x plus 2x, that gives us 3x, and we still have plus 3 is equal to 5. And now we're just solving a basic level 2 two-step equation. And so we have 3x plus 3 is equal to 5, so we're back to our algebraic rules. We'll subtract 3 from both sides because we want to isolate the variable. The 3's cancel out, and so 3x is equal to 5 minus 3, which is 2. And then in the end, we want just 1x, and so to cancel out the times 3, we'll divide by 3, always doing the same thing on both sides. And so we find that x is equal to 2 over 3. Now we're not done because we want to solve this system of equations for both x and y values, but starting with finding a solution for x really does a lot of the work for us because we have an equation for y in terms of x right away. So we can plug it right in, and now if we plug in 2/3 right into the variable x, then we'll have y is equal to 2 bracket 2/3. Again, whenever we're putting a value of a variable inside of a variable, we're always putting inside brackets to write our solutions properly, and then plus 3. Now, hopefully remember how to multiply your brackets. 2 times 2/3 is 4/3 plus 3. And now you can change 4/3 to a mixed fraction, for example. So that'll be 1 and 1/3 plus 3, and 1 and 1/3 plus 3. We'll finish that off on the left here, is 4 and 1/3, or if you'd rather, 13/3. Okay, either way. And so your solution for your system of equations would be that x and y are 2/3 and 13/3. Okay, and this is how you write your final solution. Okay, so again, substituting our equation for y in terms of x into y into our second equation lets us solve for one of the variables, and then we can plug that back in to the first equation that we haven't used yet. That's important, plugging in our solution into the equation we haven't used yet to solve for our second variable, okay? So we're going to do something similar for example 2, but now we have to establish the equations that are not given to us. So we know that the perimeter of this rectangle is 36, and we know how to find the perimeter of a rectangle. We add all 4 sides. And so if we do this for a rectangle here, we'll have x plus y plus x plus y, or if you'd rather, we have 2 x's and we have 2 y's, and so we can write 2x plus 2y is equal to 36, right? We then are told that our area is 56, and the area of a rectangle is length times width, and so that tells us that x times y, length times width, x times y, or xy, is equal to 56, okay? Now, again, I'm going to use substitution because I do think that this translates better to more complicated functions later on. And so this first equation, 2x plus 2y is equal to 36, we can factor the left side. You might notice that we can factor a 2 out of both terms. And if we do so, we'll have 2 bracket x plus y is equal to 36. Okay. Now we're back to our grade 8, grade 9 algebra. We can get rid of the 2 in front by dividing both sides by 2. And so now the 2's go away. And we have x plus y is equal to 36 divided by 2 is 18. And now we don't need the brackets because they're not doing anything productive. So we can just get rid of them. And we have x plus y is equal to 18. Now this looks a lot like one of the equations we have in example 1. And so we can use some algebra to get y in terms of x. We can also get x in terms of y. I'm just going to go with y in terms of x for this example. So x plus y is equal to 18. If we want to get y all by itself, much like it is here in example 1, see how y is equal to all the stuff with x. Let's do the same thing here. If we want to get y by itself, we want to get rid of the plus x, and the same way that we get rid of the plus 3 by subtracting 3 down here, we can do the same with variables. And so if we want to get rid of the plus x, we can simply subtract x on both sides, and so x minus x goes away. And now we just have y on the left side. And on the right side, we have 18 minus x. Okay. Now this, much like our first equation over here, is y in terms of x. It is an equation for y in terms of strictly x. Okay? So that allows us to substitute this in to our second equation. Okay? You see how we wrote our equation from the very start based off of our diagram. Now we use some algebraic manipulations to get y in terms of x. And now we can substitute the expression for y in for y. And so that'll become x times, we're going to replace the y with the expression for y that is purely written in terms of x. And so we'll have 18 minus x, and this is still equal to 56. Now what we have here is a simple binomial expansion. Monomial times a binomial, we just multiply through with the distributive property. And so x times 18, that'll give us 18x, and then x times x means minus x squared is equal to 56. Okay? And we can do some algebra to kind of make that look a little nicer. We're so used to having quadratic functions in the form x squared, then x, then the constant term equals 0. So what we'll do is, you can do this many different ways. I'm gonna add x squared on both sides, and I'll subtract 18x as well on both sides, both in the same step just to save a bit of time. And so there will be nothing left on the left side, and so we'll have 0 is equal to, let's write this properly, x squared minus 18x plus 56. Okay? Now that we have a quadratic, now that we have our quadratic formula that actually represents this diagram, let's rewrite it here so it's a little bit nicer looking. X squared minus 18x plus 56, right? Now we're looking to solve this quadratic. Now hopefully you've done quite a bit of work with factoring quadratics and solving them, because we're looking for two numbers that add to make negative 18 and multiply to make 56. I recommend thinking of two numbers in this sense that add to make negative 18 and multiply to make 56. Now we can look at the factors of 56. This will help us think through our options for pairs of numbers that would work in this situation. And so what are the factors of 56? Well, we have 1 and 56, then we have 2, and we have 28, then we have 4, and we have 14, and finally we have 7, and we have 8. And so now we have to think to ourselves, which of these pairs of factors add to a sum of negative 18 and simultaneously multiply for a product of 56. Now you can run through those if you want to take a bit of time to do this on your own, just pause the video. I'm gonna go ahead and notice that 4 and 14 fit the bill, but only if we use their negative value, okay? And I'll remind you that a negative number, negative 4 times negative 14, produces a product of positive 56. Two negative numbers multiply to make a positive product. And so if we use negative 4 and negative 14, negative 4 plus negative 14, those do have a sum of negative 18. And at the same time, negative 4 times negative 14 also produce a product of positive 56. And so we can go ahead and factor this quadratic as x minus 4, x minus 14, okay? And this tells us that if 0 is equal to this bracket times that bracket, then any solutions to this equation would mean that this bracket is equal to 0, so x minus 4, excuse me, x minus 4 is equal to 0, or x minus 14 is equal to 0. And so we have two options for a solution for x. If x minus 4 is equal to 0, then clearly x is equal to 4. And if x minus 14 is equal to 0, then clearly x is equal to 14. So these are two options. We have two possible solutions. And I'll remind you of our expression for y in terms of x. Whatever x turns out to be, we know that y is equal to 18 minus x. And so for solution 1, y is equal to 18 minus x, which means if x is 4, we have 18 minus 4, which is 14. For option 2, if x is 14, then y is still 18 minus x from the equation that we found earlier. And so y is equal to 18 minus 14, and so y is equal to 4. And so this is not something that should surprise us, because there are no restrictions on the dimensions of a rectangle, of the geometry of a rectangle. And so we can either have x equals to 4, y equals 14, or we can flip-flop, and vice versa. X is equal to 14, where y equals to 4, okay? Both of those solutions satisfy the conditions that the perimeter is 36, the area is 56. You can check it if you really want to, but I hope this kind of helps, one, give you confidence on solving systems of equations, getting one variable in terms of the other, again, y in terms of x, or x in terms of y, works all the same, and then setting up kind of a problem in geometry or a word problem, and seeing the utility of solving systems of equations in an example that at least kind of everyone can make sense of, okay? So please let me know if you have any questions, comments, requests for future videos, always appreciated, and thanks for watching.